Section 8.6. In the following problems, they're asking us to compare these given quadratic functions and answer the following questions: up or down, wide or narrow, or the same shape as the generic quadratic function, very basic formula of f of x is equal to x squared. To answer this question, we're going to compare it to our given standard form, which indicates some components that will answer the question. We'll look at a, the leading coefficient, to tell us whether it opens upward or downward. It opens upward if a is positive, downward if it's negative. We'll be able to tell the vertex from the h and the k, the axis of symmetry, and as far as wide or narrow, has bearing on the value of a. If a is greater than 1, the absolute value this is greater than 1, then the parabola is narrower than our generic x squared. If a is between 0 and 1, and again this is the absolute value, then we have this pancaking or wider situation going on in comparison to f of x equal to x squared. So on this first function that we're given, and we compare it to x minus h with an a coefficient squared plus k, we don't have some of these components. We have 1/3 times x minus nothing squared plus k, which is a 0. There's nothing being added on here. So comparing this, and essentially all we need to do to answer the particular questions here is to look at a. We can also fill in some additional information. Is it up or is it down? Well, a is equal to 1/3. Whatever our squared term is being multiplied by gives us a. Well, our squared term is being multiplied by 1/3. Since a is greater than 0, in other words, it's positive, this parabola will open up. Since the absolute value of a is between 0 and 1, and it clearly is, the absolute value of 1/3 would be 1/3, is between 0 and 1, it means that we are going to have a wide parabola. So to answer the two questions, we would say it's opening up and it is wide. To further investigate this in the event they asked a graph, comparing it to the standard form, the h is 0. There's nothing being subtracted before it's squared. There's nothing being added on. The vertex of this parabola would be at the origin, 0, 0. There's no translation. And our axis of symmetry, which is x equals h, would be x is equal to 0, essentially the y-axis. In this next problem, same questions are being asked. To answer these, we are going to set it equal to our standard form of a times the quantity x minus h, quantity squared, plus k. To determine an up or down, we'll find our value of a. A is our coefficient on our quantity that's being squared. So a is equal to a -5. Since that is less than 0 or negative, it means that the parabola would be opening downward. As far as wide or narrow or same shape, if the absolute value of a is greater than 1, it means that we have a narrow parabola. And the absolute value of -5 would be 5, which is clearly greater than 1, so we would answer that this parabola is narrow, or at least narrower than the generic f of x is equal to x squared shape. Again, this is going beyond what's being asked, but because we're just on the cusp of graphing any parabola, To analyze this further, we can determine the vertex, which is hk. There's nothing being subtracted from the x before it's squared, so our h is 0, and our k, the signs agree, so our k is 3. Our vertex would be at 0, 3. We have a translation of our basic f of x is equal to x squared, 3 to the right. Our axis of symmetry is x equals h, which would be, in this case, x is equal to 3. In this last example, they're asking us the same questions. So we'll compare it to the a times x minus h quantity squared plus k. A is the coefficient on our quantity that's being squared. It appears a is equal to a negative 1. When a is less than 0, in other words negative, it means the parabola will open down. Wide or narrow, if our absolute value of a is greater than 1, it will be wider. Well, if we plug in the negative 1, absolute value is 1, 1 is not greater than 1, it equals 1, which means it will be the same shape as the basic quadratic function of f of x is equal to x squared. Again, this is beyond the directions, but in anticipation of eventually graphing and identifying vertex and so on, we can further identify the h value. Since the signs agree, they're both subtraction, our vertex hk will have the ordered pair h of 1/5. We don't have the same sign, so a plus k can be transformed here with a minus 2 as plus a negative, which is making our k negative 2. Axis of symmetry generically is x is equal to h, so this would be x is equal to 1/5. So this parabola is going to look a lot like f of x equal to x squared. It will have the same shape. It will be opening downward, but we have a translation of 1/5 horizontally and 2 down of our vertex with our axis of symmetry running through x is equal to 1/5.